I'm Ellie Court, Soils for Life CEO, hosting this episode of the Soils for Life podcast. Jill Clapperton is a farmer and applied rhizosphere ecologist. She grows crops with integrated livestock in Kansas state in the US and advises farmers the world over. Talking with Jill was eye-opening and fun. We go big, talking about Gaia theory and the interconnectedness of all life on Earth, but we mostly dive deep into the fascinating ecological communities that plants create above and below the ground. As Jill explains, plants are not passive. They are purposeful masters of their own fates, wielding chemical arsenals and mustering armies of microbes to secure their survival. And if we plant with purpose, we can harness the incredible power of plants to create farming systems that are productive, resilient, and great for the soil and our health. Please enjoy my conversation with Jill Clapperton. We ran an event recently with a professor named Felice Jacka, who's going to be at the Grounded Festival in December. Her area of research is the influence of food on our gut microbiome and on our mental health in particular. And it's tempting to just say that it's all connected. The health of the soil, the health of the plants, the health of the animals, the health of us, the health of the planet. It's all connected.
It is all connected. It's Gaia. The theory of Gaia that was, James Lovelock gets all the credit for it, but it was Lynn Margulis's idea.
So who's Lynn Margulis?
Lynn Margulis is an evolutionary biologist, but she got it. She got the idea that everything is connected. And actually chemists have always had a term for it. It's called metabiosis. And it means that when we change one part of an ecosystem that allows one species to come in, then that species changes the ecosystem gain, which facilitates friends to come in. So it's sort of, if you think about it, it's like building a community. Somebody gets there and they go, oh, this is a great place to live. And the next thing you know, they brought their friends. And their friends are living there, or they brought their parents there. And before you know it, they start to be quite a community. And it's the same thing. You get plants into the pasture and they're like, their root exudates make it so that some other things can come in and some seeds can germinate that had never been able to germinate before. So they're like, oh, I get to germinate. Well, then once they've germinated, then their root exudates change everything, and that allows other things to germinate, and that allows microbial communities to form that support all these different species, and before you know it, you have a plant community. The whole idea of that's exactly the same. It's recruiting into the community, and one thing makes a change, and then other things. And the whole idea is to make that spiral or that cascading effect be very positive.
So I was going to ask, how does that work? We've gone very big already in our conversation, but how does that come down to the farm scale? You were speaking at an online session we ran the other day for crop growers. And one thing that really struck me as you were speaking was how much we still don't know and how much we're discovering at the moment, and at the same time how challenging that must be for many growers and farmers who might not be used to operating in an environment where you have to acknowledge that you're in this complex system that you can manage only so far. Is that something you find?
Yeah, that demands your flexibility. It demands you to be dynamic.
Yeah.
And being dynamic is hard. Dr. Rennie Van Acker out of University of Guelph coined the term Betty Crunker farming. So it's like cake in a box. And you add water, stir, and put it in the oven and you bake a cake. And he said, that's where we're getting to. You buy seed, it's all coated with everything. You buy the fertilizer package that goes with it. And you throw it in the ground and manage it with all these chemicals, and voila, you have a crop. And it takes the thought out of it. And I think what's happening is people are going back to, you have to think about this. We have to think about this a whole lot more than we've been doing. And we can't just rest on our laurels and think that the system is going to be super resilient. But that's the fun part of it. Okay, I know that it wouldn't be fun for everyone. I do understand that.
And so you've got a background in what was applied rhizosphere ecology, which I'd be interested for you to explain exactly what that is. But that is a knowledge-intensive background where you have studied these interactions that we're talking about, and you're still saying there's so much we don't know and it's challenging. And so, yeah, I imagine there would be people who would be apprehensive hearing, I can't do the Betty Crocker approach.
Yeah, but just because it's complicated for me and I'm sharing sort of the knowledge of how things work, doesn't mean it has to be overly complicated. I think sometimes we overcomplicate things. It's okay to just know that the crop is great. I think we got into this whole mindset of we need to have this big economy of scale, which means that logistically speaking, you have time to navel gaze or just sit back, or I did this and yeah, it seemed to work pretty well. And then you do it the next year and you're like, oh, that didn't work. But wait a minute, it worked the year before. So I'll give you an example of what I'm saying. So I put in this great cover crop the first year. I had cereal rye. I did what I've always done for a lot of people. Like, no weeds. I cleared everything up. Man, it was awesome. The wheat crop going into it was stellar. Then I got to grain sorghum. Not stellar. Not even close. So every time it rained, the crop would sit there, not do a thing. Wouldn't grow, big zero, just sit there. And then when it started to dry out, it would grow like gangbusters. This is ridiculous. Every time it rains, it's like I'm inhibiting the crop. Okay, so what is happening? What do you normally do? You go out with a spade and you go out with all your other stuff and you stand there. And you look at it all, and with some people, they would say, take your shoes off and stand on the ground and feel it and all those things. So I go out and I stand and I'm like, okay, let's just really have a good look at this because something peculiar is happening. Well, and then it struck me, I have all this rye residue still because I'm in a pretty arid climate and it was a really lush crop. I have it all sitting still between the rows. Not a lot of it, but some of it. My gosh, when it rains, these residues are breaking down, and the allelopathy from breaking down is inhibiting the growth of my crop. All right then, this is why tillage worked. Because if I'd have tilled that, all those residues would have been under there, they would have been broken down a whole lot more, and I've never seen that.
Yeah.
And I'd been never able to tell others, this is for real. And when I said that, I was at a growers meeting and I said, yeah, has anybody else seen this? And there were a couple of people there who just started laughing and they went, is that why? I said, I'm sure that's why.
Yeah.
And he said, yeah, we have seen it. I don't use rye anymore. I like oats and barley and stuff because then, he said, I really miss the rye because it really cleaned things up. But yeah, we saw that with our sorghums and our millets and stuff. They just did not grow.
And so you're speaking about the value of giving something a go, getting out there and having a look.
And there's nothing scientific about what I just told you.
Yeah.
I shared an observation. Okay, I have the background to figure out why that happened. But I shared an observation with everybody about what happened to me. That farm knowledge, that farmer knowledge, that's the key to everything. It's not me as a scientist telling you, okay, it liberated these molecules and these molecules did this, that, and the other thing. Or you having me come out and measure that because something is wrong. It was me just going, oh, there's something to do with this residue on here that is inhibiting my crop. And this farmer knowledge, and I think about what Souls for Life is doing where they're having farmers talk to one another and also telling stories. This is the important part.
And I wonder if it's partly about the confidence to say that observation of mine as a quote-unquote humble farmer, not a scientist, is something worthy.
Valuable. Yeah, it is. There's a scientist who's at the University of Oulu, Finland, Anna Kay. I'm not going to try and butcher her last name.
Well, you did well with the place name. I'm impressed with that. Sounded Finnish.
Yeah, well, you pronounce every letter in Finnish. She actually talks about the importance of farmer knowledge and how that has been usurped. Because if you can't measure it, then you can't manage it. And so the attitude is if I can't measure it, I can't manage it. And that's not true.
Well, an observation is a form of measurement, isn't it? It's
It
just
is.
been a deprioritised, devalued form of measurement.
Yeah. Yeah.
And it's not, I'm assuming what you're saying is not don't measure either,
No,
right?
I'm not
Of course,
saying that.
measure, but also value what you can observe with your own two eyes and your nose and your ears and...
Yeah. Smell your soil. It tells you a lot. Taste things. Nothing wrong with tasting stuff. Everybody's like squishing things for bricks and stuff. Chew it. I mean, I'll go into a cornfield, crack the stalk and suck on it and go, oh man, this is just acid. And people are like, really? Oh, let me try that. But what does that really taste like? What is it really measuring? But you don't even need that fancy thing. You don't need to be holding up to the light or getting a digital thing. Just crack it and eat it. Taste it. Is it sweet or is it not sweet? You'd be surprised sometimes how you would think, oh, it's photosynthesizing beautiful, and it's sour as anything.
And what does that say to you?
That says to me, the plant's struggling a little bit. It says to me that the plant is doing something with a lot of acids in order to combat something. And so then I'd better start looking around for what's going on. Because shikimic acids, when it starts putting a lot of acids in the leaves, changing the pH like that, it means that the plant is getting ready to make a lot of secondary metabolites for some reason. I dig them up. At that point, I dig them up.
Yeah.
But you don't have to be fancy, or you can be really fancy. You can use the selective ion probes from Ariba and do your sap analysis in the field. You can do all of that.
But you don't have to.
But you don't have to. If you're out in the field and it's quick, all of a sudden the sheep break out and it's, I haven't got time for this, but I need to sort this out. Then you take a quick bite of something and you're, okay, I think I have to come back to this. No, this tastes really fine. I'm okay, I can move on. And sometimes you need to do things on the fly because something else came up. And this is that whole flexibility, dynamic aspects of when you're on the farm or on a ranch. You're never standing still. You are always bending with the wind.
I love that. So you've just come back to the farm, and did you say that it's in Kansas?
Yeah, this is a family farm.
Right.
And they want to go transition into full-on regenerative. And so I'm going to live there full-time.
Amazing.
And take 5 years to turn it.
Yeah.
And I'm going to document my journey for everyone from going from here we are here to hopefully making a transition. And I know that I'll make tons of mistakes along the way. And I know I only have really 2 chances a year. So it's not like experiments where I can do things really fast and whatnot.
What's the 2 chances a year?
Well, I can grow 2 crops a year. And I have integrated livestock.
Yep.
So when things go bad, I can just feed cows.
Yeah.
But we're also working on a program of breeding cattle to be drought tolerant and getting them off of their pharma. So no pharma in our cattle. If I'm really sick, I'm going to take an antibiotic too. I'm not going to let any animal suffer, ever. I don't know anybody who can. But I've been amazed. When you think about it, you put animals on really good diets. Because I've been building forage crops for people around the world for a long time. You put them on that, and the changes in metabolism. We did this experiment where we had sheep, and we took them northeast of the United States, cool, wet springs, and the grasses, the cool season grasses are green and lush and beautiful. And then in the summer, it gets really hot, and they just decline like crazy. And then in the fall again, everything jumps back up because it gets cool and wet and great again. So these animals, if you think about sheep, then in the summertime, they're feeding on really not that great a forage. And then they're coming into breeding season. So, you know, they've got lambs that are having green, nice grass and everything else. Then they come in trying to grow lambs on basis. So we put in warm seasons and we put them on a forage crop. And then they went back onto the regular feed, onto their normal thing. And then we looked at, okay, let's look at how many lambs we have in the spring. We knew what we had before, look at the same cohort and their history. And then we look at what happened. Well, all of a sudden, our numbers and our birth rate went up. And so now we actually had multiple births. Never had multiple births up till then, like 1 or 2, but not very many. And we increased multiple births by 24%, just with that short feeding time.
And what sort of species were you introducing?
There were worm season, like we actually put a worm season cover in, like cowpeas and sun hemp, sorghums, and we had millets and yeah. But we didn't have it really super diverse. 8 species in there.
Yeah.
Sheep loved them, went crazy in there. And that's the thing, we've all noticed that when we grow these forage crops, which are really good for the soil, you have really great root systems, and then build them for the animals too. And it's great because you can wean cattle, you can finish cattle. Talk to farmers that are putting 5 and 6 pounds a day on these crops, and then putting in a cash crop afterwards and going, oh, this is amazing. And fertilizer is way down, but the lushness of the crop is up, and there's no weeds. And these are things that we really want. Some people aren't going to go there right away, and there's a lot of people are going to go, I'm not going to have stock, and I get that.
Yeah.
But that doesn't mean we can't use, like we talked about, companions.
Yeah, it'd be great to talk about that actually, because a lot of the work we're doing at the moment is with growers. So we've been talking a lot about multi-species cropping, and you've talked about that in the context of integrated livestock and the benefits for the animals and the soil. But we're also looking at intercropping and companion cropping, and maybe you could just talk a little bit about what those different things are, and then a bit about how growers who don't have integrated livestock can start thinking about some of these things.
Intercropping is ancient. Over 1,000 years ago in China, they were intercropping. Nobody ever grew a single monoculture. They always had more things in there. In Africa too, they put berries in amongst things. They'd have cassava, and they'd have other things in there too. The 3 sisters, beans, corns, and squash, of the Navajo and the Anasazi. It's well known, intercropping. If you're harvesting by hand, intercropping was pretty easy, because it didn't matter that the beans were climbing all over something, and somebody was always in there and could pick them, and you weren't trying to harvest everything at once.
Yeah.
But we're trying to harvest everything at once. So that adds this other level of complexity to it. So then you're choosing plant species that have very different seed sizes, but mature at the same time. I can seed at the same time. This is an experiment. We can go with some things that people have pioneered. We know that flax and chickpeas love each other. That's a no-brainer. We know piola, peas and canola, peas and mustard. We know they love each other. We know that many people growing them around the place, that you could probably figure out what to do. I grow wheat chickpeas. Grows really well. There's a number of people who do that. It's another one of those that's pretty easy. But again, we don't want to spend tons of money. We're going to have to spend money on seed. And we probably want to put a little bit of fertilizer, but starter fertilizer with everything. I don't care what that starter fertilizer is. It can be your slurry, it can be your compost tea, it can be your compost extract, whatever it is. And it can just be straight fertilizer. I would always put some starter with that. Everybody gets off to a good start. The key is finding species that like each other. Sometimes we choose wrong. I put sorghum and lupins together. That was a bad choice. Lupins and sorghum don't like each other at all. Millets and lupins don't like each other.
And so what happened to those paddocks?
Nothing grew. Everything was just really stunted.
Yeah.
And then some insects got in and ate one of the species. And in this case, the blister beetles ate all the lupins. And the sorghum just took off, like overnight. So what I've done when things aren't growing really well is I'll go in, I'll walk along the road and I'll clip out, or take my machete and I'll hack out a really long, like maybe 5-10 meters of one species. Then I'll go down the other road and I'll hack out the other species. And then it's amazing what happens. All of a sudden, the one that you didn't hack out, the other one's, whoa, yeah, and they're growing. And so then I have these really weird patterns in the field where I've hacked things out, and the one that is now free of the other one is, oh, thank goodness. And it works for both of them. The lupins took off when the sorghum was gone, and the sorghum took off when the lupins were gone.
So they were not happy companions.
They were not happy companions.
So that's the intercropping side of things, which is planting multiple cash crops at the same time in the same place and trying to find the ones that work together, that you can seed at the same time, that mature at the right time so that you can harvest them and separate them.
We have a lot of historical data from Asia, from Africa. If you look back, you could probably find things that people grew together that grow really well. But the problem is always going to be harvesting them, because you need to separate seeds now and all these things. So That's not for everybody. And it's all very nice because we know that, like with chickpeas and flax, there's something called out-yielding. So chickpeas alone, you get the same yield off chickpeas grown with flax that you get, and you get the same yield off flax grown with chickpeas that you would if you grew the whole field. And instead, you get two crops that you can market. You have the same amount of yield of each of them. So I've doubled my money. And lentils can go in there too, in that row. Lentils grown with flax are also very good. And then from a multi-species perspective, you can grow companions. Companions have multiple functions. You can grow a companion that will eventually be a forage. You can grow a companion strictly for pollinators to control insects in your plants. And the example I would give is in carrot seed, where we grew lentils between the rows. That attracted all sorts of pollinators, which really did in the lygus bugs. But in looking back at some of the research, we also, now that we do all this like aerial imagery, it's really cool to fly drones over these things. And now we have infrared, we have all these other cameras we can put on there. So now we can really start to look at what's going on. But what was really cool was that if you were an insect, like a lygus bug, and you were flying over carrot seed fields, that image wasn't correct. You did not have the right search image. So you're gonna go somewhere else. And they did, they went into the other field that was being managed by the seed company organically as well, without the lentils in it. And they ended up spraying lots of organic chemicals, like organic supplements and various other things on it.
So are you saying they literally could not see
They could not.
the plant that they desired?
Okay, let's look at this. If you go into the supermarket, so here you are in the supermarket, and all these apples, and they're all different colors. Then you're trying to make a choice of, well, which ones am I going to look at? Because visually it's stunning, and you're choosing. Well, these insects are flying over, and they're trying to decide what is my best shot at reproducing my species. Well, this one here that is not really solid stand is probably not my best bet. But that beautiful yellow, solid canola, solid white field of white flowers, abundance is like, yeah, I'm going there.
Yeah.
But this one's all mixed up. Now we go back to some of the research that was done at the Lethbridge Research Center with canola, and just adding in 16% barley into the canola screwed up the insects. It reduced the insect pressure by over 32%. And all it did, you're just using a bit of seed. And in that case, there was absolutely no need for insecticide anymore. So now I've just lowered my cost of production. Now, I don't know if I do barley, because then you get barley and then you're cleaning again. But a grass that doesn't green things, or even if you just had taller stubble, whatever, would be really helpful for that. So that's one way of companioning. The other one is, I just don't want weeds, I don't want insects, but I think you're planting with purpose. This is more when you're doing companions, I've got a purpose in mind. Do I want a ground cover? Maybe I want clovers in there, but you have to think about this. So if I'm growing sunflowers, I could have a sclerotinia problem. I can't have clovers in there, or I can have some other things like maybe foraged soybeans or something because they're prone to sclerotinia. So now I have to think of diseases. So the other thing I'm also trying to do is prevent diseases in my cash crop. So the last thing I want to do is promote them in something else. Companions can also be bait. They just be straight out bait. Here, have this one. It's all yours. They can also be for root diseases, because we know that certain plants deter nematodes. So maybe if I've got a possibility of a nematode problem, so for example in coffee, you can have stubby root nematodes and stuff. Well, then maybe what I want to do is between my rows, I want to grow some brassicas, some mustards occasionally mixed in, so that the nematodes just can't take it. And that would be the same for fruit trees. So sometimes with nut trees and fruit trees, because I mean in Australia, you're growing walnuts, pecans, things like that. Same with the trees. Walnuts are very prone to root knot nematodes. And oftentimes we're growing grass and clover. Well, that's a bad choice. Because now planting with purpose tells me I can actually prevent some of that nematode damage to my walnuts by simply planting a brassica. A few brassicas, forage rate. I don't even have to plant a lot of it. Forage rate, maybe some mustards in with other grasses and some flowers. Woohoo!
Yeah. And what's the mechanism by which that happens?
That is called allelopathy. So plants actually, so a lot of medicines, but mostly a lot of poisons, actually come from plants. Strychnine is a really good example. And like tobacco plants, people don't realize this, but with tobacco, the tobacco plant actually adjusts its chemical, its secondary plant metabolites, depending on what the chewing is of certain insects. So it'll produce more of one particular chemical when it's being chewed on around the perimeter. But if it's being poked holes in the middle, it produces a completely different chemical. People think plants are just passively just taking it. They aren't. And that's that whole thing of tasting them. Sometimes you can tell things are going to happen or something's gone wrong. And wine, like vineyards. People who taste the grapes, okay, they can taste the terroir, but they taste the flavor of the grapes and there's something going on here. But they can also taste the effect of what's growing between the rows.
So those companion crops can put out chemicals that will deter the nematodes, not just for themselves, but for their companions, which is the cash crop that is threatened by nematodes.
So that whole thing of everything's connected is now all the plants in that community, my trees, everything I'm growing in between, they're all connected.
Yeah.
And so now they're going, oh, you need this. I don't want those. Here, have some of this. Yeah. This stuff works really great.
Like a good neighbor.
Yeah, and they're also sharing. So if insects come in and they start chewing on the leaves, plants send out aerial signals. They send out gaseous signals that say, oh, you need to armor up because they're here. Everything will start producing jasmonic acid and shifting things, and photosynthesis will go down because they're shifting into secondary plant metabolites. And this is where your fertility is really important, because sulfur is the number one element and trace minerals that plants need in order to do defense. And it's the same for us, it's the same for everything. And so this is where when people stress your tissue test, do you have enough minerals? That's the important part. What does your mineral profile look like? Because they're going to need it at this point. And that can be a problem with nitrogen. Use too much nitrogen, that blocks a lot of these trace minerals in the plant, and then they can't defend themselves. And so you, in your attempt, or as a farmer, our attempts to have big, tall crops and abundance and everything, we're actually blocking the plant's ability to defend itself. And so then when disease comes, it comes and it just ravages our crop. And part of that's our own fault in the way we manage.
And then we need to reach for the tools, the chemical tools.
And I reach for them. Why not? A lot of people, a lot of consumers don't understand, don't realize that. Farmers don't make a huge margin on the crops they grow. And my whole profit is made in a very short time span. 6 months, 7 months, 5 months, 4 months, depending on where you are in the world. I'm making all my profit for the entire year in that short time period. I haven't got the rest of the time. Oh, I got sick and okay, I missed out on a week's worth of work, but okay, I can make that up here and do a bit of this and here. I don't have that choice. And that's why you see farmers that's gonna go, well, okay, I learned X and X, and this is the important part. Learn from the mistakes or learn from the year, and then you apply it the next year. But that's how it goes. I'm carrying all that over to the next year.
And potentially don't bet the whole farm on an experiment. You mentioned on the call the other night that you do your experiments in the garden.
Yeah, I do some experiments in the garden. Sometimes I'm like, how does this grow?
Yeah.
How does it taste? Can I make it grow this way? And then some things, like I want to plant safflower. I like safflower, and safflower has a lot of great benefits in it, and it's really drought tolerant, doesn't get diseases, and attracts all beneficials. I'm not very competitive with weeds, so what could I grow with them? What doesn't outgrow it? What grows over it? So, this is where you have your little patch. In my case, some of it's in the garden, some of it's in the 30 acres, where there's just a whole bunch of patchwork stuff in there. Can I grow sesame? Well, I could plant 50 acres of sesame and fail, or maybe succeed. Or I could just plant just some plots of sesame with a little 10-foot drill and see if it grows even. I know that some people near me grow it, but I don't know if on my soils, which are very actually different from theirs, if it's really going to grow for me. And when do I seed it? So I sesame seed, I'm planting it all these different times, and I'm planting it at different rates, and then I'm planting it with some other things in between so that I understand the plant.
Yeah.
So I get one season where I can like, okay, what does this plant grow like? Because at first I didn't even know what it looked like in the field, and I was like, oh, that's sesame. You have no market for them, so what's the point? But sometimes it's not about the market for it. It's about, this is my cash crop, but that would be an excellent companion for them because that doesn't support any of the diseases that this plant has, and it would grow in between, and it would give them the benefit of having beneficial insects. And honestly, I look at herb books, like medicinal herb books. I read herb books and go, oh, so I got a whole bunch of seed for anisesept. Put anisesept in. Well, who would have thought that the cows are like, oh, anisesept. Woohoo! This stuff is really sweet and tasty, and all the bees were all over it. Same with borage, just things like that. And I just put little patches here and there, or I'll put a strip in so I don't spend a whole bunch of money on wild seeds, and then put a fence between the two, and then just watch the cows to see which one they like. And sometimes they tell you, they're like, they go in and it's, man, this is like ice cream, and it's gone. And the other one is, oh, I guess I can go back and eat that. No, maybe I won't. They've got their own wisdom about what they need, and absolutely. And you just need to pick out, you want to have something in there that they want. So that's another way to increase your diversity. And you don't have livestock to do that. You just have to think about diseases and what am I putting in there.
Yeah.
And then, of course, you've got cover crops, and if you can do a cover crop, great. Where I am, we really struggle. When I was farming in the Pacific Northwest, we really struggled to get covers in. And it's the window of time for a cover crop.
Yeah.
In Australia, people struggle as well, like in the summer, to get a crop in that's actually going to do anything. How do we sort that out? You just try, and then you find species that maybe you can grow, maybe you can't grow. And you know what? Maybe you just, instead of having bare ground, what we call solar sterilizing your ground, let some of the weeds grow really well. Just don't let them go out of control, but watch them, because I saw ground the other day that just had stubble in it and was going to stay that way for a while. And at 40 degrees, do you know how hot that soil would be? And how hot it would be at depth? Do you really think all you've done is sterilize your soil?
Yeah.
And Australia was the first research organization to talk about fallow disease.
One of our case study farmers, Grant Sims, was at an event recently, and he said that soil's at the same temperature or hotter than the Bain Marie, where your food is put to stop bacteria from growing. So what's it doing to the bacteria in the soil?
You've sterilized everything.
Yeah.
So now what plants do you expect to grow now?
I think the other challenge that I hear about with all of these, with companion cropping and intercropping and multi-species, is moisture competition. I don't know how you think about that.
The one thing I'll say is that the data is very clear when you actually do the analysis. When you have multi-species, and that's the key to all of this, everybody in the world over has shown that the moisture stays underneath. I have a reflective residue on the soil. So now I'm reflecting. So now we're actually thinking about physics of light. Instead of transmitting all the light and holding it and all that latent heat, now I'm reflecting it back. I've got a light colored residue on there, and I can play with the color residues with my covers and stuff. But I've got a light colored residue, it's reflective, I don't have as much heat. And now I measure the temperature under there, it's not hot, I am not evaporating that water, I'm actually insulating that water. Now when I go to seed, there's another issue there. It's like now my soils are a bit colder, but in the next 3 years, if I keep that up, my soils will actually be warmer again, because the biological activity in there will actually have created more heat. And so what we find is that we actually have snow melt where the soil is really biologically active because it's warmer. And it can be 3, 4, 5 degrees Celsius warmer, where the soils are biologically active. Once we have built up some more organic matter and stuff, than they are somewhere else. So it can work both ways.
When you're planting, you've mentioned planting with purpose. Does that come into the consideration of what to plant and when in terms of moisture conservation and maintaining the moisture needed for the cash crop?
It does. So if I'm going into a year where I'm really struggling for moisture, I may not plant companion, because nothing's going to grow between the rows anyways. So I'm going to try and canopy over. I might narrow my row spacing, or I might spread my row spacing out. I might plant companion. So now I'm going to use technology. I'm going to play with row spacing. I'm going to play with what goes between. I might tighten the rows up so I canopy over, because if you put your hand under the canopy, you'll notice that you can feel the coolness under a canopy. You've got things cooling off underneath there. The other thing is with moisture, I want the plant to be recycling moisture a little bit. If I'm insulating the soil, if I've got enough residues on the soil in the first place, then particularly for trees, fruit trees, nut trees, if I can insulate those roots, they will maintain their transpiration stream, which means I'll maintain calcium and boron going in, especially into flowering, which means I'll stop flower drop, I'll stop fruit drop. I'll have a better chance at really having a good nut crop or a good fruit crop by just insulating and maintaining the cool temperature. Because when the roots of any plant can maintain a constant temperature or a little bit fluctuation, but maintain a physiologically active temperature, they keep working. Things go up, things come down, but if they get too hot, they can't work anymore. And the whole plant closes down. And that's why sometimes with cool season plants, and I've seen this, I have moisture in the ground and the plant's dead. And you're like, that cannot be. And because people are like, oh, it's drought. I go, no, let's go. We're gonna dig right now. Let's go dig. And we go and dig, and there's moisture in the root zone. Temperature in there, hot, so hot. Well, that's a heat thing. The plant just can't grow. The roots are too hot. And if the roots are too hot, then they won't work. That means that your above ground can't get water either, and the whole thing just, that you're done. And that's why we can weather. So this is about resisting weather. How can I be resistant? Well, that insulation makes me a little bit more resistant to just the vagaries of climate, where I get 2 weeks of really hot, awful weather. Well, now I've got armor. That plant's gonna slow down, but it's not gonna die. And then when things go back to a bit more normal, it's gonna grow again. So this is where I'm looking. And the other thing when you ask me about planting with purpose is I'm also looking at root zone competition. So if I'm growing a shallow rooted crop, I'm gonna grow a deep, something with deeper roots in between the rows. If I'm growing a deep rooted crop, let's say sunflowers, really going deep, then I'm gonna go shallow stuff in between the rows. And I'm probably gonna go some nitrogen and things like that, but I'm gonna go shallow roots because I don't want things competing in the root zone. I wanna have a root canopy. I don't wanna have everything at the same level. That's not my goal. And so I am thinking about moisture. I am thinking about competition for moisture. But I'm also thinking the more organic matter I put in the ground with roots, the more resistant I will be to drought. The greater water holding capacity I will have. Because I want to be able to say to Jimmy Emmons someday, is he'll say to you, how much water you got? I want to be able to say to him, all of it. How much waste did you get the other day? All of it.
Yeah.
I want to be able to say that truthfully, that every drop that fell on that ground, none of it went off. I pulled in all of it because I have such water holding capacity that every drop of that water was held in that soil.
Yeah, and it's that resilience to the variability in the weather conditions, but it sounds like also responsiveness. You know, you did talk about looking at the seasons and planting accordingly, adapting. You approach what you plant and how you plant it according to what the season's looking like.
Seasons are changing. Climate change is real. We've all noticed it. We've been living in, scientifically speaking, from the papers I've read, we've been living in a time of very, maybe uncharacteristically calm climate. Very little change, really stable. Now all of a sudden it's tumultuous.
And when you say we, you mean human beings?
Yeah, human beings in general.
Yeah, for our history as a species.
Yeah.
Yeah.
I mean, at least from the climate scientists that I follow, I said that the last 30 to 40 years have been really stable climate. And that's all changed. And where people would say, oh, I'm in a winter rainfall zone. Now I'm going, no, I think I'm going to try summer crops. I think I'm going to plant spring. I'll plant winter wheat, but I might still only go half my acres that I would normally plant winter wheat in and put half of them winter wheat and half of them spring wheat and hedge my bets. Now I'm like a hedge fund manager. I'm like, well, I'm going to hedge my bets here.
Yeah.
Here's my climate hedging.
Yeah.
And then I'm also seeing in areas where they've always grown cool seasons, we can put warm seasons in.
Yeah.
All of a sudden, when you never consider corn or sunflowers or anything like that, it's like, I think I could do it.
I'm really struck by how that's another layer of thought and another lens on the decision making. It's just one more layer on top of the layers of, I guess, a more dynamic, knowledge-intensive way of thinking about farming. And I guess I wonder, given that a lot of farmers may have been schooled in the Betty Crocker farming approach, and now there are all these opportunities and benefits to be had from planting with purpose, from working with the amazing technology of nature. How do you guide people into that if they are feeling maybe apprehensive?
Well, first of all, it's overwhelming.
Yeah.
Let's just call a spade a spade.
Yeah.
It's overwhelming.
Yeah.
Sometimes you just feel overwhelmed and you're like, I haven't a clue what I'm going to do next. Maybe you just have to take a moment, sit back for a minute, maybe go out and, I don't know, build something in the shop. Or in my case, go and bake something. Or maybe go and thrash a bunch of bread dough or something.
Yeah.
But you just need a change of venue because you're feeling overwhelmed. Too many choices. And we've got all this technology too. Do I buy another drill? Do I do this? Like, how do I use what I've got? I want to try this, but I don't know how to try it. Some of it is really like what you're trying to do with Soils for Life. Put peer groups together. They don't have to be big. Like when I was in New South Wales, we just went over some close neighbors, and we went for a little ad hoc field day. Oh, let's go see what you're doing. Oh, you didn't get any frost on that. What do you think happened there?
Going from one brain thinking about a problem to 5 is 5 times the thinking. Yeah.
And in Argentina with the Acrea groups, and actually Andre Voisin from France actually started working in South America with some of these groups, creating little peer groups. And they never exceed 8 people. Now turns out that there's a real reason for that, is because decision-making tanks. As we go over, it just becomes almost unwieldy. So if we thought we were overwhelmed, once we get too many people, too many cooks in the kitchen, it's overwhelming. So you have small groups of people with like minds. When you think about it, you have 8 farmers together. You have 8 really top-notch agronomists thinking about a similar problem. Well, did you try that? And if they're all in the same area, they all have similar problems. They have similar climate. Okay, maybe I have slightly different soils. So in the case of where I was near Wagga, you've got, people that had layers of aluminium, like this big layer that was like 10 centimeters thick at one point. And then you've got people that are just distributed aluminium. And then you've got people who are actually on basalt, people who are on more quartz and things like that. Okay. And everybody's got quite slightly different issues. And they're all dealing with them differently. But then maybe it's not a field day, but just a little group chat. Just visit somebody's farm for just a morning. Let's all have coffee and then let's go out and take our coffees out to the field and have a chat. When I'm in Argentina, it's take the mate out, pass the mate around, and go and and chat about what's happening.
And I think a lot of people might think that a peer group has to be a very formal thing or something that's funded or really well set up or well thought through. And I think what you're saying is, no, it just needs to be a group of like-minded people, neighbours getting together and having a chat or visiting something.
And you don't have to formalize your group if you don't want to. In Argentina, they have the Association of CREA, which actually formalizes peer groups. You can have an agronomist with it and keep notes. In southern Alberta, we have 3 peer groups like that where they actually have an agronomist that works with them and keeps track of their notes and even does experiments on some of the farms and will source equipment. So one time, the first group that I worked with when I was a scientist at Lethbridge, because I was so impressed with what was going on in Argentina, I said, hey, how about we try this? And they were all like-minded. And so we did. And you know what we'd really like to? We'd like to try a stripper header. Okay? We get the stripper header, and okay, well, we'll all chip in. We'll put it into a fund, we'll get a stripper header, we'll try it. So that year, everybody shared, and then it was a problem because it worked so well. Said, I'm going to finish. No, you can't, because I get to try it too. And then after that, everybody had stripper headers. I'll give you another example of the power of that group. It was the trial. So somebody said, okay, we want to play with drills. 5 of us have hoe drills, and we're doing direct seeding with hoe drill, but we'd like to do discs, but we don't know which one, and then there's knives and all these things. So the agronomist who was working with the group, Rob, went out and he goes, okay, well, we've got this group of farmers and they want to buy a drill. And so we've allotted this land and you can bring your drill out, bring it fully ready to go. We'll provide the seed, but bring it ready to go. We can hook our tractor on, or you can bring your own tractor, whatever. Well, 4 drill manufacturers brought their drills out to the farm. This was not a field day. There's 3 of us here that are going to buy a drill. We don't know which one, but we want to see how it performs on our soils. Well, one guy didn't come prepared and thought, I'll just throw something out there. And then realized that this was actually really serious. There were 2 groups at that point. So there were 12 farms out there, all representing a lot of acres, deciding on drills. And it depended on the outcome of this. You all got the same seed. Everything was the same. Land's the same, go up and come down and you're done. And then we're going to evaluate this over the year.
Love it.
And one manufacturer, I'm not going to say which manufacturer it was, sold 3 drills at the end of that season. Actually, he ended up selling 4 because I happened to have a visitor from Utah who was visiting, and I said, we're going to go see what's happening with drill day. You might as well come and have a look. And he bought one too. And so that manufacturer, based on that one trial, sold 4 implements based on that day. And that's the power of getting groups together and deciding on what you're going to do. So that was one thing to do. But then I've got a problem and I don't know what it is. You've got a bunch of people out looking at it. And honestly, some farmers are really good at bending metal. And maybe you need something done. Or maybe you're building something like in the peer group, the international peer group that I coordinate called Life Unlimited. So a perfect example of one of our peer group members here in Australia, my son wants to go overseas. Oh yeah, he's working on one of the members' farms. Yeah. And we only meet once a year. We meet once a year, we talk online, we have a WhatsApp group. Those members are from all over the world. And my goal was to bring people together from all over the world and people who are struggling in their community. They're doing great things from a world perspective, from a country perspective, from all perspectives, but the community doesn't support them at all because they're weird. They're doing weird things, they're way too successful, and we hate them. And those people, and I was like, well, who teaches those people? Those are the people who are at every field day, who are speaking at all the meetings, trying to tell people what they do, but who supports them? So I decided that they could support each other, but we have this group. So we have members from all over the world, and once a year we meet at somebody's farms. We share amongst ourselves, but it's very supportive in whatever we do. Like somebody has a death, somebody has some other things, everybody is there for that person. If there's a problem, we're there for you. We don't want anybody not to feel supported in their community. And we know that there's people all over the world that struggle with the same problem.
Well, I think that's a great place to end, Jill. I have loved this conversation and really appreciate you taking the time in a layover between flying in from Perth and flying off to Launceston. And so what else is happening over the next little while you're in Australia? How long are you here for and what are you doing?
First of all, I'd say I've also really enjoyed the conversation. It's been really fun and really far-ranging, which I love. So for me now, I'm actually going on vacation. I'm going to go hiking in Tasmania.
Lovely.
I'm going to go whiskey tasting because I'm a whiskey connoisseur. And I'm going to go out with Robin Tate for a day and visit some farms just because some of them are just to see what's going on in Tasmania. I'm really bummed that I am missing the Grounded Festival. The Grounded Festival. I've been reading about it and I'm just like, oh. And people ask me, they say, I'm coming back for the Grounded Festival. I said, no, I'm committed to something else.
Yeah, little plug for that is the 4th of December.
I'm big plug. 4th of December. I think it's going to be fantastic. Yeah. I just looked at it and I think it's such a good idea.
Yeah. At Matthew Evans' farm near Hobart in Tasmania.
And I love groundswell. I think this is a lot like that. I think it's just going to be, I just wish you all really well. And I hope that if you ever have it again, I can come.
We'll make sure to get you on the guest list early. Yeah.
But instead, I'm going to go and learn about cover crops in my area of the world.
Lovely. Well, enjoy. And thanks again.
You're very welcome.
This episode was hosted by me, Ellie Court, and produced by Soils for Life and the Grow Love Project. Head to the Soils for Life website to find out more about our work. And if you like what you hear, don't forget to rate and review our podcast. Every review helps to make our podcast easier for others to find. If you have feedback or suggestions of people or topics we should cover, you can reach us at info@soilsforlife.org.au. We love hearing from you. Thanks for listening.